This is a re-recording of the lecture from January 25th, which did not record correctly in the lecture hall. Today we're looking at the Creating, Moving, Removing, and Copying Files notebook. One of the underlying ideas in the Unix operating system is this idea that everything is a file. So this idea lets us model any sort of input or output operation as reading or writing to a file. So accessing a regular file or a directory or even a storage device like your hard drive, we can think of these as just performing some sort of input or output operation. So what most people think of as a computer file is just a collection of bytes. Reading the contents of a file can be thought of as reading a stream of bytes, and writing data to a file can be thought of as writing a stream of bytes. So if you're following along in this notebook, you'll want to run this cell so that we're in the correct directory, I've already run this cell once, so we're already in that directory right now. Okay, so file names in Unix are a bit unusual in that you can use almost any character in the file name. The ones that you cannot use are the file path separator character, so that's the /, and you're not allowed to use the null character, so that's \0. This means that you can use any other character, including things like the new line character, which is a bit unusual. File names are case sensitive, so the name little-case ABC is different than the file name uppercase ABC. Hidden files are files that begin with a period. So, for example, if we go into this directory here, and we use the long listing for ls, we see there's no hidden files here, but we can easily make one. So I'm just going to use this command called touch to create a hidden file. So it's going to start with a period. If I use ls to list the contents of the directory, the file .hidden doesn't appear. If I want to see the hidden files, I have to ask ls for that explicitly using either -A or -A or -lowercase a. Several characters have special meaning in the shell, so we've seen wildcard globbing or file name expansion. So we know there that the asterisk and the question mark have special meaning to the shell. Now, those characters are not forbidden in a file name, but generally it's a good idea to avoid using those characters. So there's a list here of characters which you might want to consider to avoid using, because these all have special meaning to the shell. In addition, you probably want to avoid using the hyphen, especially as the first character of a file name, because that might be interpreted as being an option to a command. Spaces are also, it's a good idea to avoid using white space in a file name. If you want to use spacing or a space, you can consider using the underscore character instead of a space. This will just make working with your file names a little bit easier. Okay, so we haven't seen how to create a file yet in this course, except through redirection. Now, when most people work on their computers, where they're using a graphical user interface to their operating system, they create files by using some sort of program, like Excel or PowerPoint or something similar. If you want to create a text file on an operating system such as Linux, there are other ways to create files. So the first file we're going to look at is the touch command, which I just used in the console a minute ago. Touch will create one or more files if they don't already exist. The files that get created are empty files. So for example, if we list the contents of the directory, we see that there are there's a file called file1, but I don't have a file2 or file3. So I can use the touch command to make the files, file 2 and file 3, which we can see here. Notice that when we use the command, it sets the modification date to the current time, which makes sense because we just created those files. If a file already exists, then touch will update the modification time of that file. So for example, if I do touch file 1, and we look at the modification time of file 1, we see that the modification time of file 1 is now the current time. So touch will create a new file if it doesn't exist. If the file already exists, it simply updates the modification time. If you want to create a directory, then the command to use is called mkdir, so short for make dir. So if we list the contents of the directory again, we see that there's a directory called dir1, but we don't have any other directories yet. But we can create those directories using the mkdir command. So mkdir dir2 dir3 will create the directories dir2 and dir3, which are right there. You can create a single directory or multiple directories. So if I wanted to, I could make another one called dir4, and that creates a single directory called dir4. If you wanted to create a hierarchy of directories, so for example, a new directory, and that directory has a new directory, and that directory has a new directory, and so on and so on and so on, you have to pass an option into mkdir. So for example, let's try the notebook example here. So I'm going to make a directory xxx, and inside that directory, I want a directory called yyyy, and inside that directory, I want a directory called zzz, and that fails. Now the reason that fails is because, as far as mkdir is concerned, we're trying to create this directory called zzz, but its parent directories yyyy and xxx don't yet exist. So if you want to create a hierarchy of directories, you can pass in the option -p. So the -p option is short for parent, so create the parent directories if they don't already exist. And if we type that, that works. So we can see there's a directory called xxx, and inside that directory, we can see there's a directory called yyyy, and inside that directory, we can see that the directory zzz has been created. Alternatively, you can make the directories one at a time, as shown in the notebook. Right, so make the directory xxx, then make the directory yyyy in xxx, then make the directory zzz in yyyy. The tree command will display a tree-like structure of your directory. So for example, typing in the command tree, assuming it's installed on your operating system, produces the following picture of the files directory. So you end up with a picture that looks sort of like what you would see in your file manager program in your graphical user interface-based operating system. You can redirect the output from a command using the greater than or operator, which is the redirection operator. So instead of producing output to the terminal, you can redirect it to a file. So for example, we can redirect the output of the cowsay command to the file called moo.txt. Right, so when I run that command, notice that there's no output generated to the screen. I can do it in the terminal as well. So for example, cowsay moo. Right, normally that produces output to the terminal, but if we redirect it to a file, the output that would normally go to the terminal now gets redirected to the file. And so redirection is another way of creating a new file. If you want to append to an existing file, then you can use the double greater than operator. So for example, if I append a new message to the end of moo.txt, right? Again, we're redirecting to a file, so no output is generated on standard output. But if we look at the contents of moo.txt, right, we see the original output from the previous redirection, and because we're appending to the file, we get the second cow, right? If you, oops, sorry, using the single greater than symbol, that will overwrite a file if it already exists. So if we redirect the output of cow say again to moo.txt, this time just using the single greater than sign, right? Again, no output to standard out, and the contents of the file are just the contents of the most recently run command, right? So we've overwritten what was in the previous version of moo.txt. The mv command is the command that you use to rename or move a file. So if you want to change the name of one file to a new name, you use the syntax mv, then a space, then the name of the file that you want to change, then a space, and then the new name of the file. Right? So for example, if we create a file called a file, let's see if there's one called a file. There isn't, so let's make a file called a file, and there it is. I can then change the name of a file to b file by using the mv command, like so. Right? And we now have a file called b file instead of a file. If you want to move the file to a different directory, you can do so. Right? So for example, we have our directory called dir1. I want to move b file into the directory dir1, and I want to rename it at the same time. So I want to move b file into dir1 and call it c file. So we can type in that. B file is now gone from the current directory, and if we look in dir1, oops, sorry, there's now a file called c file. Now, you don't have to rename the file when you move it. So for example, let's create another file called z file. If I want to move z file to dir1, but leave its name the same, I can just type in move z file, and then the directory name. So z file is gone. But if we look in dir1 now, there is, you can see the file z file that we've moved to that directory. So renaming or moving a file to an existing file name will overwrite the existing file, and there's no way to recover the overwritten file. So if you want a warning that you are about to overwrite a file, then you can use the -i option. So for example, let's make some files, x file and y file. So there they are. Now I'm going to try to move x file on top of y file. Sorry, this time using the -i option. And you'll see that when I run this command, right, it now asks, do you want to overwrite y file? So you can type in y for yes, n for no. So let's type in y. And you can see there is no x file anymore, and y file is actually contains the contents of x file now. Removing files. So in Unix, file deletion is permanent. So there is no reliable way to recover the contents of a deleted file. And this is considered to be one of the problems in the design of Unix. So if you click on that link there, you can, well, let's click on that and see where that takes us. Right. You can see here that, here it is, file deletion is forever. So the command that removes files is called rm. Right? So the remove command removes a file or files. And to use the rm command, you simply do rm fname. Now, as a warning, what you don't want to do on your system, you don't want to go into your home directory and type in something like, so let me make a temporary directory first, and then I'll show you what not to do. So touch. I'm just going to make a bunch of files and maybe make some directories. Right, so now we have a directory that's got a bunch of stuff in it. What you should avoid doing is going into your home directory and typing in something like remove minus r star. Right. So this version of remove with the minus r option recursively removes everything in the recursively remove anything that matches that pattern. Right. So star. Oh, let's do star. There we go. So remember, star matches everything that's not a hidden file. So this command here will recursively remove everything in this directory and its subdirectories, right? Like so, right? Everything's gone now. So whatever you do, don't run that command in your home directory because that will delete everything in your home directory, including whatever work you have in that directory. And again, there's no way to reliably recover the contents of a file after it's been deleted. If you have administrator privileges on your computer, and you probably do, although you'll be prompted for a password, you'll have to enter the command in a different way. Don't go into the root directory and type in rm minus r star. If you have administrator privileges in that directory, you will actually delete your entire operating system. And obviously your computer will eventually crash because all of your files for your operating system will be deleted. So be very careful when you use the rm command. Make sure that you're in the correct directory, right? If you're using wildcards, be very careful about using the star wildcard because you may end up deleting files in a location that you don't mean to be deleting them from. All right, so let's look at this command here. So we have making several files called a through e.text. So we can do that. Let me go back up. Okay, so touch a.text, b.text, and e.text. Right. So now we've got a bunch of files that end in .text. Right. So I'm going to remove. We can remove a single file, right, like that. And notice a.text is gone. I can remove more than one file, so b.text and c.text, right? And I can use the wildcard or pattern matching or globbing, I guess, to remove multiple files as well. I'm not going to use this command here because this deletes the file big a.text, which I want. Instead, I'm going to use the square bracket notation. So I want to remove d and e dot text. So I can do that, right? And notice that d.text and e.text are now deleted as well. You can use the -i option just like we did with mv. So for example, remove -i and then moo.text. This will now prompt the user if they want to remove it. So I'm going to say no in this case, right? And it doesn't remove it. What else is there? I guess that's it for RM. Obviously, if you specify a name that doesn't exist, so something like that, it will fail, and you'll end up with a non-zero exit status. Okay, rmdir will remove an empty directory. So we're going to make a directory called sumdir. All right, so I'm going to remove make an empty directory called sumdir, which we can see right there. And then I'm going to remove that directory. Right, so now that directory is gone. Right. Okay, so if I make a directory called sumdir and then I add a file to that directory, right, so it now has a file in it, rmdir will no longer work, right? Because rmdir only removes empty directories. So you either have to go into the directory and remove all the files from that directory, or you can use rm with the -r option to recursively remove sumdir and all of its contents. Right? And now sumdir is gone. So the cp command is the command that you use to copy files from one file to a second file. You can also use it to copy multiple files into a separate directory. But you can't copy multiple files onto multiple different files in with a single command. So with cp, you pass in the name of the file that you want to copy, and then you give it the file name of the new file to create. So for example, I can copy a.text onto a new file called awords.text. That, right? And we now have a.text and awords.text. If we look at the contents of the files, right, you'll see that they are identical. Right? And that makes sense because awords.text is just a copy of the contents of the file a.text. If you want to create a copy of multiple files, you can, but the only way to do so is to place the copies into a separate directory. So for example, I can copy everything that starts with a capital A, all the files that start with a capital A and end in .txt into the directory dir1. So let's look in dir1 first, right? Oh, they're already there. So let's go into dir1. Let's remove dir1. So I'm just going to remove everything from directory 1. Right, so directory 1's still there, but there's nothing in it now. So I'm going to copy I'm going to copy a.text and awords.text into dir1. So a star txt into dir1. And if I look in dir1, you can see that those two files are there. And if we look at the contents of them, we also see that the contents are the same as the files that in the current directory. If you want to copy a directory and its contents, you can use the -r option to recursively copy all the directory and all of its files into another directory. So this command here will copy the directory dir1 into a new directory called words. So now you see there's a directory called words, and if we look at the content of dir1 and words, right, you'll see that they are the same, right? So dir1 has those two files there, and words has the same two files there. If you were to go in and compare those two files, they'd be the same. If you were to compare those two files, they'd also be the same. And so that's how you copy files in Linux. All right, so linking to files. So remember that a hard link is a directory entry that maps a file name to an inode, right? So remember, a directory is just a file, right? Inside that file, you can imagine that each row of the file contains an inode and the file name that refers to that inode, right? Or that maps to that inode, right? So for example, in this directory, if you run the ls command with -i, and -i will print the inode number, and 1, so that'll do 1 column output, you might get something that looks like this. Obviously, it'll be a little bit different because we've manipulated the directory. So you can see here, you can see the inode number and then the name of the file name corresponding to that inode. Okay, if you use the long listing, so -l, then we'll get more information about the files in the directory. Right? So in the long listing here, with -i, you get the inode number, but then you get a bunch of other information as well. So the information in this notebook that I'm after is this column here. So that's the number of hard links. So for a file, regular file, that's the number of hard links to the file with that inode. Right? For a directory, right? So dir1, dir2, dir3, these are the number of directories contained in each one of these directories. You can see there's 2 directories in dir1, 2 in dir2, 2 in dir3, and so on and so on. In X, you can see there's 3. So let's go into the XXX directory. Right, so when you list the contents of that directory, you see there's only one directory. You say, well, there's 3 hard links. Where are the other 2 hard links? Right, so don't forget that every directory has a link to itself, right, called dot, and a link to its parent directory called dot dot. So that's where the 2 comes from, right? So 2 of your hard links in a directory are the directories dot and dot dot, and then there's a in XXX there's another directory called YYY, so that's our 3rd hard link here, right? dir1, dir2, and dir3 they don't have any subdirectories. So if we go into dir1, right, we have some files, but no subdirectories. So dir1 contains 2 hard links. When we go up to this directory here and run that ls command, right? So when you're inside a directory and you list the contents of the directory and you see that there's a subdirectory in that directory, then the number of hard links that's printed here, that's just the number of directories that are inside of that directory. Okay, so the ln command can be used to make hard links and soft links. So with this version of the command right here, we're going to create a hard link, a second hard link to the file called a.text, and we're going to give that the name a. So let's try that and see what happens. Right, so ln a.text, so that's the target, and then this is the name of the hard link to create. Right, you can now see there's another file called a, right? In addition to the original file a.text. So let's do this following, right? And now we can see, right, that when we list the contents of the directory asking for the inode number and the long listing, we can see that a, right, refers to the inode 51753. A.text refers to the same inode, right, 51753, and you can see that there are 2 hard links to that node right there, to that inode there, right, because we have 2 files that both refer to the same inode. So what happens in this situation here when you create a hard link is that you have 2 files, right, a.text and a, right, but they both point to the contents of, they both point to the same contents on your disk, right? So in other words, a and a.text, if you use either of these if you edit either of these files, then that changes the contents referred to by that inode. So if I edit the file using a, for example, as shown here, right? So I'm going to append to the end of a, sorry, echo ATM, right? Instead of printing that to the screen, I'm going to append it to the end of a, right? So if I output or print the contents of a, I should see ATM at the very end, right? But remember, a and a.text, they both are pointing to the same inode or both refer to the same inode. So if I also print the contents of a.text, you'll see that it also has the word ATM at the end now. Right? So effectively what I have here are 2 file names, both referring to the same file data. Right? So editing the file using the file name a modifies the same data that a.text would. Okay, so if I have exactly one hard link to an inode, then removing the file by name causes the inode to be deleted, right? So, right. But that's not the situation we have here, right? I have two file names that both point to the same inode. Sorry, this is happening because I'm running the online version of the notebooks. Right. So if I remove A, right, the file A is gone, right? But a.text is still here, right? And furthermore, right, the contents of A still refer to the inode at 51753. Right? Oh, notice that the hard link count has decreased by 1 because we removed the previous hard link A, right? So there's only one hard link now to this inode. All right, so a soft link maps a file name to another file name, right? So a hard link maps a file name to an inode. A soft link maps a file name to a file name. So for example, I can, to create a soft link, you use the -s option with ln, right? So the first name is the target. So a.text, so that's an existing file. And then I want to create a soft link to that file. Right? We're starting with A, like so. Oops, words. Sorry, let me delete that. I guess I already had that link. Oh, so there we go. Right. So if I list the contents of the directory now, right, you can see that I have the file a.text, right? I've got words starting with A, right? And you can see that when I ask for the long listing, you can actually see that it's a link. So I have a arrow pointing to a.text, and there's an L in the first character of the long listing, right? So that L indicates that this is actually a link and not a regular file, right? So a regular file has a hyphen as the first symbol. So here we've got a soft link to this file. Words starting with A is a soft link, right? So in other words, it's a name of a file that points to another name, right? So you can imagine that this is actually pointing to the name a.text, right? Which is different than a hard link. So for example, right, if I ask for the inode numbers, right, so a.text refers to the, has an inode 51753, right? So that's where the information for a.text lives. Our link has a different inode number, right? 51763 instead of 51753. Right. So our link here is actually pointing to the name a.text. Right. Okay. So if I edit the file using either name, right? So in this case, I'm going to append a wall to the end of one of these two files. Right? If I look at a.text, you'll see that the word AWOL is at the end. Right? And if I look at the file word starting with A, you'll see that AWOL is also at the end. Right? But that makes sense because words starting with A, right? That's actually pointing to, right? That's a link to the file name a.text, right? So when I write into words starting with A, that's the same as writing into the file a.text. Right. Okay, so what happens if I... Okay, so what happens if I change or rename the file that this link is pointing at? Right. So if I move a.text to little a.text, right? Now this link, right, no longer points to the file a. Right. So sorry, the link maps to the file name a.text, but there is no file called a.text in the directory anymore. Right? So notice that in my shell, or in my terminal here, the link gets colored in red, which indicates that this is an invalid link. Right? If I try to do something with words starting with A, right, it's going to complain there's no such file or directory, right? Because there is no such file or directory called a.text. Right? So this is called a dangling link. If you look in your directory bin, so let's go to the directory root bin and list the contents of that directory. Right? You can see that there are many files in this directory, right, that are actually links to some other program. Right? So xzcat is actually a link to the program xz. Right? It's actually a little bit more complicated than that. So if we go into the root directory, you can see that the directory bin is actually a link to the directory user bin. Right? And this happens in many of the Linux distributions. So instead of having to type in user bin or root user bin to get to a command that happens to be in that directory, you can just type in root bin and get to that and get to those commands that way. Right? You can see there's lots of soft links that are created in your root directory, at least on my Linux distribution. Right? So the file name rootlib is actually pointing, the directory rootlib is actually pointing to the directory root userlib. Right? And the directory lib32 is actually pointing at the directory root user lib32. Right? And sbin points at the directory root user sbin. And so the many Linux distributions make extensive use of soft links to map names in many directories to other directories. If you are working in a directory in your home directory somewhere, and you need to access a file that's located in some other directory frequently, right? Then you can create a link in your directory that points to the other file, and that way you don't have to type in the full path or the absolute path or the relative path to the other file every time. You can just use the link to get to the file. And so that's occasionally useful as well. I think I'll stop there for this lecture. And in the next lecture, we're going to look at the expansions notebook.